Number one, the first thing it is asking for is the increasing intervals. So that is where the graph has a positive slope. So that would be here, this section right here. And we're listing the x values. So this would be an x value of -8 with a square bracket, because this is a filled in circle down here. And then this is the x value of -6. Anywhere else there is a positive slope would be here. And those x values are -4 to -2. Where is there a decreasing interval? That's where it has a negative slope, which would be this section here. We list the x values, which is -6 to -4. And then we have this other section here. It's got a negative slope from -2 as an x value to +6. End behavior always starts the same. As x goes to -infinity, what happens to y? And as x goes to +infinity, what happens to y? So as x goes to -infinity means we're going to follow our graph to the left, because x is getting negative when we go to the left. What happens to our graph? There's a solid point right here, which means y stops at whatever that y value is, which is -9. As x gets bigger towards +infinity, we're going to follow our graph right. Our graph stops right here. That y value is -7. It will not always be infinities. If there's arrows up or down, it would be positive or negative infinity, depending which way they pointed. If they stop at solid points, then it's whatever that y value is. Looking at number 2, we're going to find the roots. The roots is where it crosses the x-axis, which is here and here. So for part A, this is -4, -5, -6. And this other one is +3. The positive intervals is wherever the graph is above the x-axis. So that would be this section here and this section here. So this section here on the left, we're using the x values. So that is positive between -8 and -6. Over here, it's positive at 3. And then following the graph forever right means that x is going towards +infinity. Where the numbers are, because that is part of the graph, we're using a square bracket. Where the infinity is, it's a regular parenthesis. Now we're going to do the negative intervals. It's negative where it's below the x-axis, which is this section right here. And it's negative when it starts at -6. And it's negative, negative, all the way until we hit 3. And make sure those are square brackets. It's only an open parenthesis if there was an open circle. If it looked something like this. If there was open circles. End behavior for part D. As x goes to -infinity and as x goes to +infinity. So as we move left, what happens to our y values? Our graph stops right here, and that y value is +9. So y goes to +9. As x goes to +infinity, what happens to your graph? Well, the graph keeps going up, and if the y values keep going up, then y goes to +infinity. Taking a look at number 3, we are asked to find the y-intercept. The y-intercept is where it crosses the y-axis, which would be right here. So that would be the point -1, 2, 3, 4, 5. So that would be 0, -5. Now we're asked to find the roots. The roots is where the graph crosses the x-axis, which is here and here. So you can write your answers two different ways. You could write x equals positive 5 and x equals negative 10. Or you could write them as points, which would be 5, 0, and negative 10, 0. Absolute minimum is the lowest possible point. So if you just follow your grid down, this is your lowest possible point, which would be the point negative 2, negative 7. If it asked you for an absolute minimum value, then your answer would be negative 7. Absolute maximum is the highest that your graph ever gets. So if you follow your graph up, it never stops going up. It would even continue off of this page. So for D, there is no absolute maximum. End behavior. End behavior is the same thing every time. We always start off as x goes to negative infinity and as x goes to positive infinity. So what you're going to do is you're going to start your graph in the middle, and as x goes to negative infinity, you're going to go left. And our graph stops right here. So you want to see what y value that is? That's the y value of 0. So y only goes to 0. As x goes to positive infinity, if you follow this graph, it never stops going up. If it never stops going up, that means that these y values just keep going towards positive infinity. Number 4, the first thing we are asked to find is the y-intercept. That is where the graph crosses the y-axis. So the answer to part A is the point 0, 0. Depending on your answer choices, it could also be y equals 0. Positive intervals. The positive intervals are where the graph is above the x-axis. So in this case, or in every case, it would be whatever section falls above the x-axis. So you're going to use the x values to state those. So this section starts at negative 8, goes up, it stays positive, and then it stops being positive right here when x is 0. So that would be square bracket negative 8 comma 0. Then nothing's positive for these x values. Then starting right here again, this section is positive. Since that does not cross at a whole number, you have to do a little bit of an estimation. I just went ahead and said that that was 6.2, comma. And since this graph keeps going forever, as it keeps going to the right, the x values are going towards positive infinity. The negative intervals are the x values where your graph is below the x-axis. So for part C, this is the only section here that is below the x-axis. It starts being negative here, comes over, stops being negative there. So this x value right here is 0. This x value right here is 6.2. Absolute maximum is the absolute highest point of the graph. So if you follow your graph up, this is a high point, this is a low point, And then this graph keeps going and going and going and going and going. So in this case, since the graph keeps going up for part D, there would be no absolute maximum. This other high point, this other peak, this would be a relative maximum if this problem asked you for it. So a relative maximum is just any high point, just not the highest. And this would have been the point -4, 8. Absolute minimum is the lowest point possible on the curve. That would be right here at the point 4, -4. I'm sorry, 4, -5. It's hard to read with all of my scribbling. That's the point 4, -5. And then end behavior always starts off the same way. As x goes to -infinity, and then as x goes to +infinity. So as x goes to -infinity, we're going to follow our graph to the left. Our graph stops right here. So we need to follow it over, and that means that y just goes to 0, comma, y goes to 0. As we go from x goes to +infinity, we're going to follow it to the right. It keeps going and going and going forever right. It also keeps going forever up. So y goes to +infinity. Taking a look at number 5. Number 5 wants increasing intervals first. So increasing, we're going to start from the left of the graph. And this section goes up. So that's going to be our increasing interval. Well, where does our increasing interval start? So this arrow means that this graph keeps going and going forever to the left. So we don't know where it's coming from. So we're going to say -infinity. And it's increasing, 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 increasing until we get to right here, which would be the x value of 0. Part B is your decreasing intervals. Well, decreasing, once we hit this 0, this other side, the y values go down, or this part of your graph has a negative slope, and it keeps going and going and going forever. So it starts decreasing at 0 and keeps going to +infinity. Part C are the positive intervals, and that's the interval of x values that are above the x-axis. So we're talking about this section of the graph. So from -6 to +6. Negative intervals are the section of the graph that's below the x-axis. So it's from the arrow all the way to -6. So the arrow is showing you -infinity to -6, and then over here, 6 to +infinity. Part E, end behavior, starts the same way every time. As x goes to -infinity, and as x goes to +infinity. So as we follow our graph to the left, our graph never stops going down. If the graph never stops going down, that's when y is -infinity. On the right-hand side, as x is getting bigger, we're moving to the right. This graph still keeps on going down over here. So again, y goes towards -infinity. Number 6, we're going to find the y-intercept. The y-intercept is where the graph crosses the y-axis. So A, you could write it as y equals 0, because that y value is 0 there, or you could write it as the point 0, 0. Roots are where the graph crosses the x-axis. There are 3 of them. -6, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, 121 This one's at 0, and this one's at 5. You could also write them as the points. -6, 0, x is 0 would be 0, 0, and then 5 would be 0, 0. Positive intervals are the sections of the graph that are above the x-axis. So it would be this section right here. So that would be between -6 and 0. And then this section over here, which is between 5, and then this graph keeps going and going and going, which means our x values go towards positive infinity. The negative intervals is where the graph is below the x-axis, which would be this section here and this section here. So this graph on the left, we don't know where it's coming from. So it's coming from negative infinity. And it stops being negative right here at -6. And then it starts being negative again here at 0 all the way to 5. And behavior always starts off the same way. As x goes to negative infinity and as x goes to positive infinity, which way does your graph end? So going to the left, where x is negative infinity, this graph never stops going down. So y is going towards negative infinity. As we follow to the right, this graph never stops going up, which means y is going towards positive infinity. Okay, number 7 requires a lot of things. I might need some more room to write here. Okay, y-intercept is where your graph crosses the y-axis, which is here. So for part A, our answer is 0, 0. For part B, roots, or where does our graph cross the x-axis? We have 3 of them. First one is -3. The second one is when x is 0. And the third one is when x is 5. I'm just going to kind of cross these out as I go. If you wanted to write these as points, you can. On your quiz, it's either going to be multiple select or multiple choice, so they should be pretty easy to distinguish. Increasing intervals are any parts of the graph that have a positive slope, which would be right here. So this x value is -1, and it's positive until we get, and I'm going to cheat and say that that's right on 3. That was my intention when I drew this graph. So -1 to 3. Decreasing intervals are the sections on your graph that have a negative slope, which would be these 2 yellow sections here. And you're going to use the x values. So this is -6 to -1. So part D is -6 to -1. And then from 3 all the way, this is going to keep going and going and going. If it keeps going right forever, it goes towards positive infinity. Decreasing. Positive intervals are the sections of the graph that are above the x-axis. So that's going to be this section right here. So for part E, the x values are from -6 to -3. Over here, it's this section, that's this peak, which goes from 0 all the way to 5. The negative intervals is where the graph is below the x-axis, which starts here and ends here. So F, those x values are -3 to 0 with square brackets. And then starting here, which is 5, and it keeps going right, which would be positive infinity. Relative max and relative min come next. So relative maximum is a maximum point, but not the highest point. So I tend to like to do absolute first. E, F, G, H, I, J. So absolute maximum is the absolute highest that this graph gets. So if you notice, this graph has a definite point right here. So that is the highest point. This would be your absolute maximum point, which is at -6, 9. So that would be I. Any other peak would be a relative maximum. So we have this other peak point right here, which is at 3, 6. That would be your relative maximum. And I'm sorry I'm going out of order. It's just the way my brain works. Absolute minimum is the lowest your graph goes. Well, if you follow this graph down and down and down and down and down, it never stops. So there is no absolute minimum. Any other minimum or valley point would be your relative min. So right here, you have a relative min at -1, -3. That fills these. You did absolute minimum. Symmetry, is there anywhere on your graph that you could fold it vertically or horizontally to make it match? The answer is no, so that's not applicable. And then lastly, end behavior. Always starts off the same way. As x goes to -infinity and as x goes to positive infinity. So as we follow this to the left, what happens to your graph? Well, your graph stops right here. So your y value only goes towards +9. It doesn't go any higher than that. As x goes to positive infinity, so as you're following your graph to the right, your y keeps going down because your graph has that arrow, so your y goes towards -infinity. Last one, number 8, relative maximum minimum. So relative maximum is if you have more than one peak point. We do not have more than one peak point. We only have one peak point. Since we only have one peak point, that would be your absolute maximum. So I'm going to skip around again. That would be -4, 8 for absolute maximum. Since we don't have another peak, like if it looked something like this, we would have two other relative maximums, but we don't have that here. All we have is that one absolute, so there is no relative maximum. Relative minimum, again, if our graph looked like this instead, these would be your relative minimum points, but all we have is this straight going down on each side, so there is no relative minimum. Part D, absolute minimum. On the left-hand side, following this down, it goes on forever, and so does the right-hand side. So that means there's no stopping point or no absolute stopping point. So this is also not applicable. So if it looked like this, let's say, and instead of arrows, it had dots, whatever the lowest point would be your absolute minimum. Symmetry, is there a line that you could fold this paper in half? Left to right or up and down? Yes. You could fold it in half right here. At the point x, at the line x equals -4. End behavior starts off the same way as x goes to -infinity and as x goes to +infinity. What happens? So x going to -infinity, we're going to the left. This keeps going down forever. So y goes to -infinity. On the right, following it down, or to the right, following it to the right, it keeps going down. So again, over here, y goes to -infinity.